Hello everyone, welcome to Learn Spring Boot with Bingyang. In this video, let's implement paging and sorting. But first, why do we need paging or pagination? Let's look at our API document. This is the API document of our Hogwarts Artifacts Online project. You can find the link to this document in the description of this video. Look at the first endpoint, findAllArtifacts. This endpoint finds and returns all magical artifacts, like this. During the development phase, this works very well because there are just a few example data in the database, like in this case, only 6 magical artifacts. Returning all of them to the front end is not a big deal. But imagine that after the system has been used for, say, 3 years, it accumulates a lot of data, maybe thousands of artifacts. Returning a large amount of data at once can be slow and resource intensive, both for the server and the client's device. My favorite example is Google Search. When you search something, does Google return all the results at once? Of course not. It only returns the first page of the results. And in most cases, a user may be only interested in the first 5 or 10 results. Again, think about Google Search. In this video, I will introduce a technique called paging or pagination that can help divide a large dataset into separate, manageable pages. Let me show you what I mean. Let's go to the slides. You have all used pagination. The idea is simple. Rather than return everything from a large result set, the front end only requests a small portion of the data at a time. We call that a page. This can be done by using 2 URL parameters, also known as query parameters, to influence the starting page number and the page size. For example, let's make the page size equal to 2. This means 2 items per page. Assume we have 6 artifacts in the dataset. So our entire dataset is split into 3 pages. In a production system, you want to have a larger page size, like 10 to 50 items per page. Here, you can see a pagination UI component in the front end. When a user clicks the Page 1 button, what happens behind the scene is that the front-end JavaScript code will make this request to the backend. Pay attention to the portion of the URL that comes after the question mark. There are 2 URL parameters, page equals to 0 and size equals to 2. This will request the first page with 2 artifacts in it. When a user clicks the Page 2 button, the JavaScript code will make this request to the backend. When a user clicks the Page 3 button, the JavaScript code will make this request to the backend. With this, let's go back to the API document and make some changes to the findAllArtifacts endpoint. As you can see, I've already added 3 URL parameters in this endpoint. The version of this document is now changed to 3.0.0. You already know page and size. The third parameter is sort. It tells the backend how to sort the artifacts in the returned page. For example, here is how to sort by artifact name in ascending order. By default, it is ascending order, so you don't need the AIC here. If you want descending order, you can use this syntax. By default, sorting is case sensitive. If you want to sort while ignoring case, you can use this syntax. Here, we're sorting by artifact name in descending order while ignoring case. If you want to sort by multiple properties, you can use this syntax. In this case, we first sort artifacts by ID, then sort them by name. Well, this example doesn't make a lot of sense, but you get the point. If you want to sort by multiple properties, but switch sort direction or case sensitivity, you can use multiple sort parameters, like this. Let me go back to the first example. Okay, if we use page is equal to 2, size is equal to 2, and sort is equal to name, ASC, here is the response from the backend. The content has the returned page of 2 artifacts. Other JSON properties contain details about the pagination. Page number is the current page number. Since we're starting from 0, so 2 indicates the third page. Page size is the number of items per page. Here, 2 items per page. Sort is an object indicating if the data is sorted. In this case, it is sorted because sorted is true and unsorted is false. What is an offset? This is the offset of the first item on the current page relative to the total dataset. Here, 4 means skip 4 artifacts. The first item on this page is the 5th item overall. Paged and unpaged are Boolean values indicating if the response is paginated or not. In this case, paged is true. Total pages is the total number of pages available. Here, 3 pages. This information is important for the front end. The front-end JavaScript code can use this information to render the pagination UI component. Total elements is the total number of items in the dataset. Here, 6 items. The front-end JavaScript code can use this information to show the total number of artifacts in the database. Last is a Boolean value indicating if the current page is the last page or not. Here, it is true. The front-end JavaScript code can use this information to disable the Next Page button in the pagination UI component. Since this is already the last page, there is no next page. Size is the size of the current page, the number of items on it, 2 in this case. Number is another way to indicate the current page number. Similar to page number, here 2 for the third page. Sort is similar to the sort object inside Pageable. It indicates the sorting status of the data. What is number of elements? This is the number of items on the current page, here 2. This number is usually less than or equal to the page size, if this is the last page. First is a Boolean value indicating if the current page is the first page or not, here false, since it is the third page. If this were true, the front-end JavaScript code would disable the previous page button in the pagination UI component. The last property is empty. It is a Boolean value indicating if the current page is empty. Here it is false, as there are items present. Okay, now let's go to IntelliJ and update this endpoint. Let's create a Git branch first. Paging, sorting. Git, switch. Let's go to Artifact, Controller first. And let's go to findAllArtifacts, right here. Based on the API document, the front end or the client side will provide 3 URL parameters: page, size, and sort. For example, the client side may make this request to this endpoint. It is requesting the first page with 2 artifacts per page, sorted by artifact name in descending order. How does the controller receive those parameters? There is an easy way to do that. In Spring Data JPA, we can use Pageable as a method parameter in a controller method to receive those parameters. So here, let's add Pageable. Now make sure you import the correct one from org.springframework.data.domain. What is this Pageable? Pageable is an interface that abstracts pagination information. Take a look at all those static methods. And let me show you some of its implementations. Page request is a concrete implementation of this interface. As you can see, to create a page request object, we need to provide 3 parameters: page number, page size, and sort. They correspond to the 3 URL parameters. Let's go back to the controller. Here we use Pageable directly in the method signature. When this request comes in, Spring will automatically create a page request object, populate it based on the 3 URL query parameters, and inject it into this findAllArtifact method so that we can use the Pageable object inside this method. Then what if the client side is not providing those parameters, like this? A Pageable object or a page request object is still created, but the page parameter defaults to 0, that is the first page. The size defaults to 20, and the data will be unsorted. So that's the default behavior if the front end or the client side is not providing those parameters. Using Pageable directly in the controller method signature lets Spring handle the instantiation and population of the page request object based on the request parameters. It is a common and a recommended approach when implementing pagination in Spring Boot. Next, let's modify this method. So we're invoking the artifact service.findAll, and we need to pass the Pageable, or to be more specific, a page request object to it. There is an error here, don't worry, we'll define this method later on. This findAll method from artifact service is supposed to return not a list of artifacts, but actually a page. So make sure you import the correct one from org.springframework.data.domain, a page of artifacts. So let's call this artifact page. Next, we need to convert a page of artifacts to a page of artifact DTOs. Fortunately, page is streamable, so we can use the map method directly. And there is no need to collect. So this map method will convert a page of artifacts to a page of artifact DTOs. So let's change the variable name to artifact DTO page. When everything is done, we can return this page of DTOs to the client side. And let me change the comment here. Let's take a slight detour from our main discussion. If you're curious about the mechanism under the hood, what happened is that an argument resolver called PageableHandlerMethodArgumentResolver resolves this Pageable method parameter. So let me show you the source code of that argument resolver class. PageableHandlerMethodArgumentResolver, second one. So let me scroll down. Read the source code of this resolve argument method. You will know how a page request instance is created. Basically, this method extracts paging information from web requests and uses pageRequest.of static factory method to create an instance of page request. Another Spring class that is noteworthy is PageableHandlerMethodArgumentResolver support. Here, you can see the default page parameter and size parameter. They're called page and size. So Spring will search the inbound web request for these two parameters, page and size. If you don't like the default URL parameter names, page, size, and sort, Spring Data provides a way to customize the URL parameter names. If you're using application.yaml, you can use those to customize the URL parameter names. If you're using application.properties format, you can use this to customize the URL parameter names. All right, now let's get back on track and implement the service layer. All we need to do is to add a new method in artifact service. And here, we're going to return this dot artifact repository dot findAll. Okay, as you can see here, there are actually many overloaded findAll methods. Now, the one we used before is just this one, findAll with no parameters. But this time, we're going to call findAll and pass a pageable object to it. Okay, we're done. This findAll method is actually defined in paging and sorting repository. So let's go to artifact repository. Go to here. Now, as you can see, this interface extends JPA repository. Let's keep going inside. So JPA repository extends list CRUD repository and list paging and sorting repository. So let's go inside here. List paging and sorting repository extends paging and sorting repository. Let's keep going inside. There we go. That's the findAll version we use. Spring Data JPA is so convenient. All right, we're done. Let's test in Postman. Let me launch it. You can also test this feature in the browser, since findAllArtifacts is a GET request. But I want to show you how to do that in Postman. So our system is up. Let's go to Postman. Here we're making an HTTP GET request, and here is the URL. Then how do we add 3 URL parameters for paging and sorting? There are 2 ways you can do this. Number 1 is that you can append this URL with question mark, page is equal to 2, and size is equal to 2, and sort is equal to name, comma, ASC. This comma ASC is optional, since by default, it is ascending order. The second way to add URL parameters is to click this params tab and add your parameters and values here. Now, as you can see, Postman is smart enough to extract the 3 URL parameters, but you can add more. All right, everything's ready. Let's click send. All right. So as you can see here, the content has 2 artifacts. And here we have the information about the pagination. Those information are useful for the front-end JavaScript to properly render the pagination UI component. Next, let's go back to IntelliJ. I want to direct your attention to the logged SQL statement in the IntelliJ console. And here in the console, ignore this error because this is a problem about Zipkin. I haven't started a Zipkin server. So you scroll up. And it's this one. So let me copy this. And paste it in a text editor. If you are familiar with SQL, this query retrieves ID, description, image URL, name, and owner ID from the artifact table. Order by name, skipping a specified number of rows, and then fetching a specified number of rows. The order by clause sorts the records in ascending order by default. The offset clause specifies the number of rows to skip before starting to return rows from the query. The question mark is a placeholder for a parameter value that will be provided at runtime. This means the actual offset value is dynamic and will be set when the query is executed. The fetch first clause limits the number of rows returned by the query. So the combination of offset and fetch first clauses makes it possible to retrieve a specific subset of rows from a large dataset. It implements pagination. The order by implements the sorting. Let's go back to IntelliJ. Since we made modifications to the findAllArtifacts controller method, let's run all the tests to make sure this change will not break our test cases. Wow, 4 tests failed. So let's take a look. Let's look at the integration tests for artifact API endpoints. Okay, recall that we modified the API response. So now, instead of .data, we should use .data.content. Because the content will have a list of returned artifacts. So make sure we add .content. Same thing here. Content. This is test add artifact success. So after we add one artifact, we're going to find all again. Then we're going to have 7 instead of 6 because we just added 1. Content. Okay, so that's for these 3. So let's run them again. Okay, good. The 4th one is actually in artifact controller test. In here, we have a test method that failed. Here, this one. Test find all artifacts success. The problem is on line 134. This line is marking the behavior of this.artifactService.findAll. But the current version of findAllArtifacts controller method no longer calls this zero-argument artifactService.findAll method. Recall that the findAllArtifacts controller method now is calling artifact service.findAll and needs to pass a pageable object to it. The findAll method in the artifact service will return a page of artifacts instead of a list of artifacts. So we need to mark the behavior of the new artifact service.findAll method. This is a good opportunity to learn how to test with pagination and sorting enabled. So let's make some modification. First, pageable page request .of 0, 20. So that's the default value, the first page and the 20 artifacts per page. Then let's wrap this list of artifacts in a page. Page implementation artifact. Let's call this artifact page. New page implementation. And let's pass in the content, a list of artifacts, and also the pageable we just created on line 137. And also we're going to pass in the total number of artifacts, this dot artifacts dot size. Okay, now let me copy this and paste it here. Now also, findAll needs to accept a pageable object. So here we're going to use Makito.any pageable.class. Then how do we mark the URL parameters using mock-MVC? So here is how we can do that. Let's create a multi-value map. The key is string, and the value is also string. And let's call this request params. Linked multi-value map is an implementation of multi-value map. Okay, so request params dot add the first URL parameter, page, and it is 0. Request params dot add the second URL parameter, size. For example, here, let's use 20. And here we can add the third one, sort. But in this test, I will ignore that. But feel free to add it there. Okay, now we're going to copy this. And after accept media type application JSON right here, dot, we have something called params. You can add parameters one by one, but here we put all the parameters in a map, so we can pass them there all at once, like this. So make sure you're not messing up the parentheses. Okay. Here we need to put dot content. Same thing here, dot content, dot content, dot content, dot content. Okay, now let's run the test again. Oh, the test passed. Good. So make sure that after modification of the production code, change test cases accordingly. Next, let's commit and push the changes to GitHub and deploy the application to production. Git add, git commit, enhance findAll artifacts with paging and sorting. git push. Okay. Next, I will go to GitHub and merge this branch to the main branch. Once that is done, don't forget to come back to your local main branch and synchronize it with the remote main branch. I will do those offline. In this video, we covered how to implement paging and sorting in Spring Boot. Pagination is commonly seen in scenarios where you are dealing with a long list of items, such as search results, product listing, or articles. Instead of loading and displaying all items at once, which can be overwhelming and inefficient, pagination breaks this data into smaller chunks, each fitting a single page. In the next video, we're introducing a feature that enables users to discover magical artifacts based on various search criteria, including ID, name, description, and the owner's name. You will learn to create dynamic queries with Spring Data JPA specifications. See you there.